And for those of you who are on iPads, change your view to be this one. The little boxes? Yeah, sorry, yeah, the graph one. Thank you. That's the word I was looking for. And for everybody else who's using paper, may I suggest you use the landscape version? So part of what we're going to do is we're going to do the ray methodology again, and we're going to assume light travels as a ray. So what are the different kinds of thin lenses or mirrors did we use when we were doing intro 2? I know we call them concave and convex lenses and mirrors. However, I have a hard time remembering this. So what I do for me is I always look at them as either converging or diverging. It just makes life easier. So here's what I mean. When I do this, I always think of either converging or diverging lenses and mirrors. When the word converging happens, think of things coming together. Whereas when the word diverging is used, think of things going away from each other. So converging, the focal length of converging mirrors is always positive. And the focal length for diverging mirrors is always negative. So that's one thing you need to remember. Then the other thing you need to remember is that we are going to have whatever lens or mirror in the middle, and we're going to have an optical axis here. We are going to consider that each lens and or mirror has a focal length, which I'm going to use 2 boxes to represent for me, but you can think of it as being 10 centimeters. So the focal length will be mentioned on both sides of whatever the optical system you have. This could be a lens and or a mirror. This line in the middle is called the optical axis. Object is placed here. Usually the objects are drawn like this. Usually the objects are placed in front of the mirror or lens. When I say the object is placed in front, that means it's placed on the left side of whatever it is. And this is called the real side for object O. This is called an extended object. So if the object is drawn like this, it's called an extended object. And it will give you an extended image. Okay, so basically an extended object has a height, and it will give you an image that also has a height. And depending on whether you're using converging or diverging mirrors, the real and the virtual side of the image will change. So the image could either be real or it could be virtual. The difference between a real and a virtual image is that a real image can be projected onto a screen. So you are able to see it. So the mirror, the image that you see in the mirror in the morning when you brush your teeth is a virtual image, right? It seems like it's behind the mirror and you cannot project it onto the screen. So in physics, those kinds of images are called virtual images. Another thing that I need to tell you is what kind of optical systems could you have? So optical systems, you could have a converging lens and mirror, or you could have a diverging lens, and mirror. When you have a lens and it's converging, you will draw it like this. A converging mirror, on the other hand, draw it like this. That to me tells me it's a mirror when I fill it in. So for a lens, I will do both sides. For a mirror, I only do one. Okay, for a diverging lens, it's a lens, so how many sides should I draw? 2. So I will draw my diverging lens like this. And I will draw my diverging mirror like that. And this is why I tend not to think of it as concave and convex, because actually, if you look at it, the mirror goes like this. And the lens actually does this. So a diverging lens does this. That's a bad picture. Whereas for a mirror, a converging mirror actually looks like this. And a converging lens has this shape. I should redraw this again. So this is why I don't generally think of them as concave and convex. I tend to think of everything as either converging or diverging. But you should know what the shapes that they look like. So a converging mirror is actually a concave mirror, whereas a diverging mirror is actually called a convex mirror. So for mirrors, that is going to be true. And it's the opposite for lenses. The converging lens is the convex lens. And then the diverging lens is the concave shaped lens. Okay, another thing I want to tell you is called, when you're studying optical systems, is called a lens mirror equation. It's 1 over f equals 1 over object plus 1 over image. And remember, these focal lengths could be positive or negative. For converging case, the focal lengths will all be positive. For diverging case, the focal lengths will all be negative. So when you use these in your equations, you're going to use plus or minus depending on whether you have a converging case or a diverging case. And then another one is called magnification, which is by how much an extended object is enlarged or reduced in size. And that equation is m equals minus I over the object height or distance. Well, in this case, it'll be the height.